Welcome to the Planet Trillion Trees podcast. I'm Eva Monheim.
And I'm Hal Rosner. We are both certified arborists through the International Society of Arboriculture. The purpose of our podcast is to encourage tree planting and proper tree care for our urban forests, which include neighborhoods, parks, and other open spaces.
We will also cover a myriad of tree topics, including the important role trees play in relationship to the climate crisis. Thank you for joining us.
Verdant Earth Educators provides dynamic in-person training and online learning opportunities for environmental and horticultural businesses. Owned by ISA-certified arborists and former university faculty, the Verdant Earth Educator team provides consultations on tree care and recommends climate-resilient opportunities for your valued green spaces. Verdant Earth Educators is all about seeding knowledge for success. Find Verdant Earth Educators at verdanteartheducators.com.
Monheim Microphones designs and handcrafts top-tier studio microphones and preamps right here in the United States in Hollywood, California. Their incredible line of innovative microphones and designs are used around the world by everyone from podcasters to top-charting record producers and singers. They recently released their new royalty microphone, Monheim Microphones Unparalleled Excellence, monheimmicrophones.com. This podcast is being recorded on May 10th, 2024. Dr. Glynn Percival is the Senior Arboricultural Researcher at Bartlett Tree Research and Diagnostic Laboratory. Dr. Percival primarily focuses on how environmental stress, drought, heat, and waterlogging influences tree growth and susceptibility to pest and disease attack. He is the author of more than 100 scientific papers, magazine articles, and book chapters, and is an honorary lecturer at the University of Reading and the Royal Botanic Garden, Kew, in the UK. Welcome to the Planet Trillion Trees podcast, Glenn. We're delighted that you could be with us today.
No, thank you very much for inviting me. It's a real pleasure to be here.
So tell us about your pathway to Bartlett Tree Experts and the extensive amount of research you've done with trees. And I see now that you are pivoting towards climate science as well. And we love to see that hybridization of those two disciplines.
Yeah, I mean, originally I'm from the north of England. It's a town called Doncaster. It's a very heavy mining industry. So it was very, very blue collar. And, ever since I was young, my dad, he was always very nature orientated. We kind of spent a lot of time in woodlands, camping, things like that. So I always had a passion for plants, really from a very early age, which is why my first job, I actually went to work for the local authorities. I served a 3-year apprenticeship, and during the apprenticeship, it was horticulture. So I would spend 6 months in a nursery, 6 months with the fine turf, the tennis courts, the golf. But my really greatest love was when I spent my 6 months with the tree team. So once the apprenticeship finished, you kind of had scope to choose where you wanted to go. So my passion was with trees. So I moved into the tree world and slowly became the tree officer. And really the pivotal moment, and this is going back quite a bit in time, was we had a prime minister called Margaret Thatcher. You may have heard of her. And she really changed the whole society in the United Kingdom. And long story short, she brought in this thing called compulsive competitive tendering, where if you worked for the local authorities, you had to tender for your own job. And to me, this was sort of the writing on the wall. But at the same time, it was kind of the motivation I think I needed to go to university, because I've been umming, because I had a good job. So I kind of moved and I went and did a degree in plant biology. And I remember during the 3 years of the degree, towards the end, you had to do a research project. And I did mine, obviously, with trees. And I had a great supervisor. His name was Stephen Reynolds. Said, you should do a PhD. And I was like, no, I didn't think I was close clever enough. He says, basically, a PhD is just like doing your research project, but over 3 years. And I was like, wow, I can do that. And I applied for a PhD in Scotland. It was called the Scottish Agricultural College Auchencruive, which is on the west coast of Scotland in Ayr. And it was affiliated with the University of Glasgow. So I spent a lot of time. And towards the end of my PhD, which was really looking about continuing my research, how stress, and when I say stress, drought, heat waves, etc., sort of impact on trees. And it kind of led me into my research now, which is obviously when you want a stressful environment for trees, all you have to do is start planting them in urban landscapes where you have traffic, atmospheric pollution, you have drought, you have soil compaction. And towards the end of my PhD, a position became available at the college to teach arboriculture. Like they say, right place, right time. So I worked in Scotland for 13 years, very, very happy. There very few, if any, researchers, with lots of foresters, Scotland, lots of forest, lots of people doing research, again, with pine trees and fir for timber production, but virtually nobody doing this urban landscape. And I just happened to be giving a paper at the University of Stirling, and the general manager at the time of the United Kingdom was in the audience, and he approached me and said, hey, how would you fancy coming to work for Bartlett? We're interested in research laboratory in the south of England. Long story short, they flew me out to Charlotte, which is where our main research laboratory is. And then I spent literally 22 years in the United Kingdom. I was based at the University of Reading. And I was fortunate being at the university. I had scope to fund PhD students, so we could look at a lot of areas of different research relating to pest and disease management and soil management. Not many people are aware of this, but we also have the Royal Warren. So I ended up working in some incredible places like Buckingham Palace and Windsor Castle, and did a lot of research with them. And I came over to the US a year ago, where I'm now permanently based. And I think one of the reasons why is one of my main areas of research was in the United Kingdom, like in the US, we found ourselves inundated with exotic pests and diseases. One of them is called ash dieback, and where there's been outbreaks in Germany and Austria, it takes out 98, 99% of the ash trees. Obviously, we have Dutch elm disease, we have sudden oak death. But in the United Kingdom, because we're such a densely populated country, we have fungicides to actually manage pests and diseases. So one of my main areas was a concept, we call it induced resistance. When we treat pests and diseases of trees, we tend to rely very heavily on application of insecticides or fungicides. But if you haven't got any, we need to look elsewhere. Induced resistance is an area which we as humans do all the time. When we go abroad, we get vaccinated. So in the United Kingdom, we decided to look at ways of treating these pests and diseases very differently based on the vaccination principle. And we wondered whether or not we could do the same with trees. So we looked at this concept where when trees become attacked by a pest or disease, there's always two factors involved. One is obviously stress. If the trees are stressed by drought or heat waves or waterlogging, it makes them more susceptible. The other is we always forget about, as I always like to ask, what makes a successful disease successful? So in the United States, Dutch elm disease killed all the elms. Why didn't it kill anything else? One of the reasons why is a successful disease is a disease that can attack a tree or a plant, actually without the tree or plant realizing it's under attack. So this induced resistance is kind of like the vaccination principle, where we can, in essence, prime the tree's own immune system, like we do with humans when we go abroad. So we started looking at a whole range of products, and there are certain chemicals, and I hate to use the word chemical because in many cases, they're actual natural products. So, for example, you may have heard of a product which is commercially available in the United States called potassium phosphate. It is not phosphate, it is phosphate. And when you apply that, it doesn't have any fungicidal properties. It actually works by switching on tree defense systems. And there's another product, salicylic acid. And salicylic acid is aspirin. And what you find is when you treat trees with some of these products, there's another one in the United States commercially available. It's called Messenger. And the active ingredient is a type of protein. It switches on tree defense systems. So in the UK, we were looking at boosting the tree's own defense systems rather than relying on insecticides and fungicides. We would literally pre-treat the trees with some of these natural products, boost their own immune system. So when the disease or the pest came in, the trees were primed. This is a big area for me now over here in the US, particularly like we know areas of California are starting to have bans on some of these products. We know it's happening in the New York area, like with the neonicotinoids, which are a soil-applied insecticide, are being banned due to environmental concerns. So there is now really a greater interest in this concept of the tree's own immune system. Just to give you a very left field example, I mentioned salicylic acid. In the United Kingdom, willow, which is the silex, are inherently high in salicylic acid, and they grow like weeds in the UK. They'll grow 2-3 meters a year. So we used to literally chip up willow trees and put them as a mulch around the base of the tree. And all that salicylic acid would leach into the root systems, switch on the tree defense systems. So very different.
I have to say that in 2003, I worked for a PR agency, and we had to come up with a way to explain this product called Messenger. Mm-hmm. And how does it work? And Messenger had another name before that, but we came up with the idea of like a vaccination. And we started using it on roses in the rose industry to see if it would do exactly what you're saying. Prime the plant and make it think it's being attacked, but it's not. And it would actually force the plant into early bloom and create a longer lasting bloom, but also create a really fantastic foliage. Mm-hmm. And it was then used because it was in the Rosaceae family. They were trying it in other Rosaceae products like strawberries. And the strawberry industry started using it and found it to be incredible because they didn't have to use a fungicide. They still use it in California. I think it's probably one of the biggest products used.
Wow.
And, I only worked for the company for a year's time, but we had gotten it out in the hands of consumers, but also garden communicators to try the product. And everyone who tried it found it to be exceedingly good, almost beyond what they were expecting. So I'm very familiar with the product, and it does work really well.
Again, what we're finding is when we kind of use these willow mulches, we would get enhanced disease resilience. The foliage tended to be a deeper greener color. We would get better flowering. And just before I came over to the US, I was involved in a huge project, which was funded by the Soil Association, where we have a huge cider industry and protect their apples against scab diseases. They used to use regular sprays of fungicide, but there's always a premium for organics. So again, our work was focused using the white willow, but towards the end, we actually found the red willows were like 4 times higher in salicylic acid and gave even better results. And believe it or not, this has actually led into a whole new area because people ask me a lot, if there was only one thing I could do to improve the health of my trees, what would that be? And I always say, well, really, you should apply a wood chip mulch. What I'm doing at the moment is I use the term pure mulch. And pure mulch is a mulch made from a single species, from oak, from cherry. Huge difference between the mulches depending on which tree you chipped up. And of course, this kind of makes sense because when you think about where do a lot of our pharmaceuticals, our medicines, our drugs, where are they derived from? They're derived from plants. So, for example, Taxol, the cancer-fighting drug, is derived from Taxus, which is yew trees. So what we find is when we apply these pure mulches, they all have different chemical makeups and they leach into the soil. And we're finding some wood chip mulches are great for protecting against above ground diseases, Others are really good for stimulating root growth and beneficial fungi associations such as mycorrhizae. And I like to use the term nature-based solutions. One of my areas has always been looking at nature-based solutions for pest and disease management. And that's really where this induced resistance falls in. We are boosting the tree's defense systems, its natural defense systems, through the use of natural products like salicylic acid and even the harpin protein, through the use of wood chip mulches, etc. Which is why, I'm over here looking at cultural control, trying to move away from this perhaps over-reliance on insecticides and fungicides. Not that they don't have a role to play, but as we say, one of the problems when you over-rely on a specific fungicide or insecticide, you get resistance buildup. But one of the beauties of the induced resistance is when you apply the messenger, for example, or the salicylic acid, believe it or not, in trees, you don't just switch on one defense pathway, you switch on about 13. You get an increase in antibodies. We call them phytoalexins. So you get plant antibody increase, and alkaloids and phenols and oils and tannins and resins, they increase and they make the plants that little bit more palatable to insects. And then the leaves get a little bit thicker and the root system gets a little bit thicker. So diseases find it hard to penetrate the leaf or the root. So as a result, it's virtually impossible for pests and diseases to build up resistance to this induced resistance effect, as it were.
Do you remember that there was a time when people would say, don't put wood chips down because it's taking the nitrogen away from the tree? And I used to laugh. I used to say, are they really serious? The wood's breaking down. It's providing nutrients. But they used to say that all the time.
Yeah.
I just thought that doesn't sound right to me. And the same thing with leaves. I would imagine that, the wood chips are going to give more, but leaves give a little bit less. Like in the fall when they're releasing all their tea.
Yes, yeah.
They're actually giving a stimulant to the plant, like a health stimulant. That's the way I always viewed it. But, what did I know?
As I always say, our own research has shown that fresh is best.
Yeah. Yeah.
Many people compost wood chips for a long, long time. And we're like, no, fresh. Literally, we've chipped up plants them straight away because all that goodness, all those products, all those naturally occurring compounds, all these organic acids and sugars and that, they're great for the soil. They have a huge impact. And as we always forget, soil, it's a living, breathing organism. And you get a huge increase in biological activity. And there is this myth perpetuating that the mulches do lock up this carbon and nitrogen. And it just doesn't happen. If you put them on the surface, you do not get that effect. If you take the wood chips and actually bury them into the soil, then you can get some carbon nitrogen lockup. But when you just put them across the surface, then you just get so many benefits. As we said, you get the weed suppression, you get the fertilization effect. It keeps the soil temperature consistent. It's a huge bonus, particularly in times of drought. If you've got that wood chip mulch, it helps conserve water in the soil. Just so many benefits.
Glynn, I wanted to ask, of course, Eva and I are just transfixed with the things that you're talking about right now. Is there ever a thought to make a tea with fresh wood chips and use it as a foliar application?
I know in the United Kingdom, some people have started to do that. And mainly, again, they were interested in can they do it from willow, for example, and they can just apply it as a spray. I think you can. My only concern at times is sometimes you can get this batch-to-batch variation. Mm-hmm. And as a scientist, sometimes we see that where people make these teas and they'll get great results, but then maybe next time they have very little effect, or sometimes it can be detrimental to trees. We just kind of prefer to chip the trees and then just use the wood chip mulch alone. It keeps those variables out of it. I'm not saying it doesn't work. A colleague of mine summed it up perfectly. He said, it's a bit like playing roulette. Sometimes you spin the wheel and you might get lucky and get great results. Sometimes you get no results and sometimes you lose that source.
Depends what the microbes are feeling that day.
One of the companies that at the same time that this messenger was going, all of it kind of came at the same time, was a company called Soil Soup. And they were out on the West Coast and they would brew tea and discussed how quickly it was applied because as you left it sit in the brewer, the nutrients went down because they kind of went out in the gaseous release. Mm. And they did a lot of research in the universities out on the West Coast on it. And just as you're saying, it depends on what's in the brew. And also, when you think about even each person or each tree, for example, each tree has different types of nutrients depending on what's available. I know they're going to have similar, but some will have more than others because of the location that they're in.
Yeah.
And that will certainly make a difference if you have to take a limb off and grind it up and chip it and put it around a tree. That's going to have a different makeup than the next tree that you're going to be pruning that may be the same species, but it may not have exactly the same amount of content. So you do have this big variable, but as you're saying, you're still going to get some really positive results from using those wood chips.
Yes, I mean, because as you say, the wood chips are more naturally occurring. And I've kind of seen a lot of these products. I use the term biologicals, where you can buy these additives to put to soil and it's supposed to contain the right microbial community. I mean, first thing is we always forget, if I was to take a mug of soil, there is about 6 to 8 billion living organisms in there. The diversity is just beyond comprehension. It's like you were saying with these soil soups. If you leave them too long, they, in essence, because they're living organisms, they start to die. And we have looked at them because, and as I always say, when I look at these products, I genuinely want them to work. You know, because if they work, you think, great, this is going to help tree care advance forward. But in many cases, they just don't because of the variability where the fungi and bacteria associated with a birch tree would be very different from an apple, very different from an oak. And many of these products just tend to be a mixture. And it comes back to the playing roulette. You spin the wheel and hope that the right biologicals are in there. And the other issue I do have with them is that they're in a sealed plastic bag.
Yes.
And they are a living, breathing organism. And what you tend to find is, we call it their shelf life. It doesn't last that long. It really doesn't. So what we did in the United Kingdom, I was planting apple trees or oak trees or beech trees. Then I would go to a well-established forest or woodland where, for example, if I had beech that were like 120 years old, and I would literally take buckets of soil because that has the right microbial bacterial communities for beech. And then when I was like planting beech, I would add a little bit of this soil into the mix. And I use the term native soil. And again, we got some great results, a lot better than many of these kind of commercial products. You know, if I was planting apple 50 to 100 years old, and the fungi bacteria are what that tree needs. And we found that was more beneficial. And again, it also was this nature-based solution. We're using natural soil from an established oak forest, a beech woodland, an apple orchard. And even if we had a mature oak tree going into decline in an urban landscape, say after construction damage, you know, where maybe the soil had been compacted or contaminated, we could literally rejuvenate the soil by bringing some of this forest soil in. You don't need a huge amount just to kind of kickstart the right biological community, as it were. So that is something else we were kind of looking at, you know.
When you're talking about these communities, and I think that that's one of the things that's really critical is when you look at a, say, for example, where I live, we have a hickory, beech, oak forest, and the mycorrhiza and the soil microbes are very specific for that group of plants. And
yes,
even though they're not the same tree, the roots graft together to share nutrients and microorganisms. And if you were trying to create that same kind of forest someplace else, that would be the ideal circumstance to get material from that type of forest, is what you're saying. And you would take it and apply it to this new forest that you're trying to create. Is that what you're trying to say?
Pretty much so, yes. Yeah. Rather than relying on, in essence, these artificial kind of biological organisms that are manufactured in the laboratory and cultured up, or, if you actually go into nature itself and use what's there, we just always found it gave us a lot better results. Our survival rates of young transplanted trees were higher. If we had trees going into decline in 80, if not 90% of cases, it's because the soil is wrong. Something has happened to the soil. If we can get the soil right, it has a phenomenal impact on the tree health and vitality. And that's always the approach, I've kind of looked at my research from, let's really focus on the soil, which is strange when I first started as an arboriculturalist, because normally the industry is above ground, etc. And over time, I've suddenly realized it's really at ground level where kind of the magic happens. You get the soils right, and the tree really just looks after itself.
Maybe this is a good time, Glynn, to start talking a little bit about your work at Stockley Park back in the UK. Eva and I both had a chance to watch the little mini doc on YouTube, and but you were very involved with the tree collection there. Can you talk about the species and then maybe take us into what you were working with in terms of compaction and the site itself?
Yeah, Stockley Park is in essence an industrial park. It's very close to Heathrow, and it's where a lot of major companies have their headquarters, such as like the Canon, the photographers, the Bayers, the Syngentas, lots of big companies. So it's a hugely heavily manicured area, primarily planted up with native tree species. We have our lime trees, we have oak, we have maple, cherry, etc. I mean, this is like 2,000 acres, huge area. We get like 25 to 40,000 people a day coming in to work, very hardcore urban environment, landscape, a lot of machinery to cut the grass, etc. A high percentage of the trees were really struggling. I mean, on average, they were growing maybe something like, 3 to 6 centimeters a year, which means it would take them like 10 years to grow 1 to 2 feet, and the other benefits of trees is trees have very powerful, what we call ecosystems services. I mean, obviously they absorb pollution, and there's all these cars and pollution that can be absorbed. The more shade you have from ultraviolet light, the more carbon sequestration. So we were brought in because overall the tree population was really struggling quite badly. And one of the major issues was soil compaction. So the dilemma we faced was, how do you decompact 2,000 acres? I mean, there are technologies to decompact soil, and they are very effective. You can do air spading, where we use compressed air. But from an economic point of view, it was just totally unviable. And I remember, again, talking to the Stockley Park people, and we were really keen to try to use some nature-based solutions. And I know at the time, actually, my ex-father-in-law, he was a Welsh sheep farmer. And what they used to do is to promote soil fertility in agriculture. They always used to add worms. And I remember talking to the people at Stockley Park, and I'm saying, yeah, you've got all these issues with soil. And I said, it really doesn't help that you have no biological activity in there. And he says, well, how do you know that? I says, well, every time I take a soil sample, there's no worms in the soil. And then it was one of these things, well, why don't we add worms? And we thought, why don't we look at the addition? Because in nature, they naturally decompact soils. So we set up this huge experiment where, in essence, imagine you've got 2,000, as we say, acres. You can't decompact it all. But what you can do is maybe decompact pockets of it, like maybe 50 square meters. So we could decompact 50 square meters and then move away and decompact another 50 square meters and move away and decompact another 50 square meters. So what we did was we had this huge area. We just decompacted little pockets using conventional technology using these airspace systems. And then we put worms and we added those to the soil. And our hope was that these worms would obviously populate these pockets of soil and then do what worms do and migrate out and naturally decompact the areas of land that were still compact. So it was a big 5-year trial. And that, in essence, is what we did. We added the worms, we added the wood chip mulch, and what we found over time was the worm population built up and literally just started to push out of these pockets and naturally decompact all the remaining soil. Weird and wonderful ideas like, well, we know the soil isn't the greatest. It's a little bit impoverished. So why don't we add fertilizers to it? Now, you can get organic fertilizers, but that kind of costs money. You can get these inorganic, these synthetic fertilizers. So we thought, well, why don't we just use some of these nitrogen fixing plants, just sow them under the trees like clover. Clover takes nitrogen out of the atmosphere, fixes it on the roots, take the lawnmower across the clover, all that nitrogen is released into the soil. So we did the story of nitrogen fixing plants, mainly clover. We looked at the wood chip mulch, and then we also added in a little bit of the native soil. And we just had some outstanding results. And in the United Kingdom, you can get it. It's called a Green Flag Award. It's a very prestigious award you can get for really bringing an environmentally friendly kind of approach to long-term sustainable landscape management. And based on this, Stockley Park were awarded, this Green Flag Award. And again, it had a huge benefit on the trees. From our perspective, it was great because it meant we could just step back and let nature do the work. We didn't have to keep going in there and decompacting. We didn't have to keep going back and adding fertilizer. We just let nature, the clover cropping, and And again, we're hoping that, using nature's own natural soil decompactors, which just happens to be worms, looking at these nitrogen fixing green manures, things like that. So
I was listening to the video and I heard some number. Was it 15 billion worms that you brought in? Do you remember how many you brought in? I was like, what?
No.
It wasn't you. Was that earlier on when the site first started back in the 80s when they brought all the worms in?
They might have done. Yeah. Long time ago.
Long time ago, because when they were first moving it was a brown site. So the refuse had to be moved, and that's what they made the golf course on.
Yes. Yeah.
And I think that's when they brought in this ridiculous number of worms. And I was like, what? And I guess over time, because of compaction of the soil and because of activity, the soil got compacted again over time.
That's because they've done so much building at Stockley Park. It's expanded so much with car parks and, as you say, the golf course and new buildings and new industry moving in. And they tend to find building construction activities just strip away all the really good topsoil. And then what you're left with is really the subsoil. It's compacted. It's devoid of nutrients. It has particularly in the UK, high pH, it borders towards very, very alkaline. So,
So what do worms do in terms of pH? Are they a factor?
Not really. We tended to find that things like the wood chip mulch that will have any major influence on the pH. That's all.
So it's interesting to sit back and kind of watch the tree care industry, the arboriculture industry evolved, Glynn, because, 10 years ago, if you went to an ISA conference and we're talking up wood chips, worms, and clover, there'd be people kind of rocking back in their chair trying to figure out where's this guy going. But look where we're going with all this cool stuff. We have issues here with worms. I'm sure you're well aware, Glynn. What's your thought in terms of how North Americans should approach worm culture?
I know in the UK we have native worms, and I kind of have researched it, and there's a lot of conflicting messages. Some papers say there are no native US worms, and other papers say there are native US worms. So, I mean, to me, my advice would always be, if it's a native worm, then yeah, it's absolutely fine. And if it will survive in those geographical areas, then I think it's something, that should be done. Addition of worms to soils to improve fertility. I mean, this is very common practice in the agriculture world. But again, in urban landscapes, no one's ever really thought about it for some strange reason. That's all, So I do generally believe it can be done. But if there are geographical areas within the US where we need to start looking at, kind of other technologies, hence like the clover cropping, for example, or, maybe the different types of wood chip mulch. So I really think it would be a case of looking at the geographical area you're in and whether or not they are native worms, because we've seen it before. Definitely do not introduce any exotics. And I mean, people tell me you guys have, is it a jumping worm? Which, well, I'll be honest, I've never seen. And I know that.
Yeah, I saw it with one of the garden communicators trips. We were on one of the properties and they have it on their property. And they said, we have to be careful when you walk. We had to have shoe covers on and then take them off before we left because of the jumping worms. They didn't want them to come with us.
Yeah. So, I mean, to me, it's just a case of looking at what we've done and selecting out which pieces are kind of useful for that specific part of the US, because obviously it's such a huge country compared to the UK, where I think each state is about the size of the UK or close to, if not a lot bigger and so forth. So, yeah.
Don't you think vermiculture has really changed how we act around worms? In other words, the worm houses in people's kitchens and, with waste and putting them out in the garden and the compost pile, making sure that they have worms there. That has changed so dramatically in the last 15 years. Just looking at vermiculture, for example, that has really made a huge difference for people in community gardens, for example.
Yeah, it's the same in the UK. I mean, as you say, using worms in composting facilities and then again adding them to the soil, it's extensive. I know, as you say, that they use them as well, different worms for like fishing, for example. But to me, it just comes back to this, and I keep using this concept of nature-based solutions. And I've always just tried to approach it from that. Look at what happens in nature, that's all. Like I say, with the tree protection, using the tree's own inherent immune system and boosting it, and looking at decompaction through the use of plants that naturally decompact soil anyway and improve fertility. And I definitely think it's the way to go. And as you say, using these worms to break down food waste for composting and then adding it to the soil, where it has been done, the results you can get can be, quite incredible. And a bit like at Stockley Park, the difference between the treated and the non-treated were really night and day. You could see huge differences.
You've sold me. I've seen your presentation, and certainly with tree planting, I would love to, make it a standard thing to add worms to the planting. How do you like to plant a tree when you are digging that hole? What are you thinking about in terms of amendments and, what's the best thing you can do on planting day?
It really comes down just to one simple factor. How good is the quality of your soil? If you have a good quality soil, and people always ask me, they were like, well, how do I know if my soil is too compact? And I'll just say, if you don't like digging it, roots don't like growing in it.
That's great.
It's like, if you're having to dig a hole and you're turning it over and the soil's real easy, the tree's going to have a great chance of survival. The other thing we always recommend is, in many cases, particularly if we buy in container-grown trees, you'll see the roots circling around the pot. You have to break that root system up. Don't just put them in the ground without teasing out that root system. Because what will happen is if the roots are growing in the pot and spiraling, odds are they will just keep growing round and round and round. And then as the canopy gets bigger, the tree becomes unstable. The hole is big enough to accommodate the root spread. And another thing, this sounds a simple thing. People so many times plant their trees too deep. If you walk away from your tree after you've planted it and it's like a pole out the ground, it's been planted too deep. you've got to pull the soil away. So you can see that little bit of kind of where the trunk hits the root system. You'll get that little bit of kind of like root growth, as it were, these thickened roots. That has to be slightly exposed, that's all. Don't have a pole sticking out the ground. So know the quality of your soil. So if you don't like digging it, you are digging it, and you notice it's totally devoid of worms, it's probably an indicator, because worms are an excellent proxy of soil health. The more worms you have, the better the soil again. And that's kind of giving you an indication that maybe what we call the biological activity of the soil is low. As I said before, soil is living, is breathing. So in those cases, you might want to look at some form of additive, maybe a little bit of organic matter, or if not, definitely without a doubt, a wood chip mulch layer, always. That has a huge impact on survival rates.
And again, you want that on the top of the tree, not in the mix.
Top, not in the soil.
On the top,
yes.
so that you don't lose. Yeah, exactly.
Yeah.
Okay.
Yeah.
Dr. Percival, if you'll indulge me, I almost feel like I want to send you like $1 million worth of Bitcoin. But before we started recording, I mentioned the article I'd seen in The Guardian from your home country. And I've got the headline, global heating to blast past 1.5 centigrade target. Planet is heading for at least 2.5 centigrade of heating with disastrous results for humanity. What does this mean for trees? What is Dr. Percival's take on the future of trees?
Trees are very resilient. They can adapt. Kind of the climate goes the way it is predicted. What we will see is just like a shift in tree populations. So as it were, let's just say the trees that thrive in Florida, for example, let's just say where I'm based in South North Carolina becomes as hot as Florida. Many of the trees here aren't going to survive, but the trees that are growing in Florida would survive. So there's kind of going to be sort of this shift in populations, because really in the US, you guys do have some very climatic extremes. Huge diversity in tree populations, that's all. So I just think we'll see a lot of movement. I know the hardiness zone of the Carolinas has moved up into an 8A now, that's all, which means it's becoming warmer and drier. Some trees that were kind of doing well here will slightly migrate further up north, and the ones down south will migrate in. So I suspect that's what will happen. But as you say, in the UK, a 1.5 degree rise would be absolutely disastrous. Many of our tree populations would just, we are predominantly oak, ash, beech dominated, and they just would not survive. Then, it would be catastrophic. So, but even in the US, heat waves are increasing in frequency and intensity, and trees themselves, leaves are obviously what produce the energy for trees. They're the main. And if the leaf system gets damaged time and time again, that is disastrous for trees. Now, leaves are designed to survive up to 40 degrees. With actually, it'll hurt them a little bit, but they'll recover. But once you get over 42, 44 degrees, that is just bad. And I know, areas in the US are hitting 47, 49 degrees, and trees just are not designed to survive those temperatures. They might be able to hang on in there for a few years, but if this keeps happening time and time again, the results could potentially be catastrophic. There is no doubt about that. Once you get above 44, it's intense.
Well, they'll be all palm trees. That's what they'll be. Lots of palm trees.
That's literally what it will come down to. Yeah. The palette will just become more and more limited.
Well, you've given us a lot to think about. And I wish you all the best with your research, because what comes out of your research is going to drive what happens in the next 10 years.
So, Dr. Percival, Eva and I are very moved by what you shared today. And, we're always looking at trends. It was so cool to hear about wood chips and their future. And I think to Eva's point that, the next decade or so are going to be very telling, not only with how trees survive, but even more importantly, how humanity responds. And so your research and others that's just kind of pulling it along for tree survivability it's terrific, and we're humbled by what you shared today. Now, with all those solemn comments, do you have a favorite tree, species, spirit tree?
I have two. And I think when I first started my career and I was in Scotland, I ended up managing an arboretum. It's not a huge one. It's the Scottish Agricultural College, Auchenproof, that had an arboretum. And there was one tree that always stood out, and it was a golden ash.
Oh, my.
So it was a Fraxinus jaspidia. And I'll never forget this tree because it actually was golden. And in winter, it looked amazing because it had golden bark. So that to me has always been a particularly special tree for me. And the other one, which I actually had in my front garden when I lived in the United Kingdom, was a Betula pendula atropurpurea, which is a purple silver birch. And everyone thinks silver birch are silver, but they're actually not. You can get purple ones, and it had purple bark and purple leaves. And it just looked so amazing to have a purple tree in the garden. So this atropurpurea has always been a favorite. The leaves are purple, the bark is purple. And I've always liked birch trees anyway, because they're great survivor trees. They're a pioneer species. They do well in these urban landscapes. They're very tolerant of waterlogged conditions. Waterlog has low oxygen, soil compaction has low oxygen. So they do really well, yet they're never planted in urban landscapes. And I'm like, they really should plant more of this tree. It's beautiful and it's pretty stress tolerant as well. So they're my two favorites, the golden ash and the purple silver birch.
Excellent choices. Are you there, Eva?
Well, I am very happy that you could come on to our podcast and share your knowledge, and for our listeners especially, to know that all of this work is being done by scientists like yourself, testing and proving the results, writing scientific papers to prove what you've done. And it can't be better than that. And we thank you so much for being on our podcast.
No, it works the other way. Thank you very much for inviting me. And as I always say, it's just great just to be able to talk to you guys and actually just get this information out there into the public domain so people are aware of it. So yeah, thank you very much for inviting me. It's just been a real pleasure.
We'll have to have you on again when you get more results.
Oh, please.
So I really would love that. So yeah.
Amen to that. Thank you so much, Dr. Percival. It's great to see you, and good luck with your acclimation to the American South.
Have a great weekend.
Okay. Thanks, guys.
Take care, everybody.
Take care. Bye-bye. The Plant a Trillion Trees podcast is edited by Andromeda Recordings in Hollywood, California.